I'm from Argonne National Lab. This is not a company. This is still an academic process. What we hope to get out of this is to determine if we have a good enough business model that Argonne will let us license the technology and form a company. So some of the questions may be a little different that we're looking to solve during this process than all the other teams. But we have the Rwedi water treatment system, which is creating water ready for use in cooling towers. So the problem on a very large scale is freshwater stress and scarcity. More specifically, we are looking at cooling towers. There are over 500,000 cooling towers in operation in the United States right now, and that number is expected to rise with increase in population. Cooling towers withdraw over 5 trillion gallons of fresh water a year. That is close to 40% of the total freshwater withdrawal within the United States. And within that, they waste 1.4 trillion gallons of fresh water a year. This is due to something called blowdown. Before I get into our solution, let's talk a little bit more about how cooling towers operate. Cooling towers reject heat to the atmosphere through evaporation that comes out of the top of the tower. The remaining water is cooled and falls into the basin. This becomes an issue when you have contaminants in your water. These are things that cause scale, corrosion, and fouling. As we go through what's called cycles of concentration, the water going through the heat exchanger, picking up heat, and evaporating the pure water out of the top of the tower, these contaminants are concentrated within the cooling tower system. And currently, there are only 2 ways to manage these contaminants. Either through chemical use to keep them suspended, which is hazardous, or through blowdown. So that's 1.4 trillion gallons that I was talking about earlier. What our solution is a technology that is placed upstream of your cooling tower, which allows you to purify your water so that you can reduce the amount of contaminants in your water and therefore reduce the blowdown of your system. So the Rwedi water solution improves water quality. Very simple. And this allows for less cost, less chemical use, and less water in your cooling tower system. This system works by having off-the-shelf components that are already commercially available and Argonne's patented resin wafer design. Very similar to the last presentation, we use ion exchange resin beads, but we put them in a porous membrane system. Then we pass electricity across the membrane, which moves the charged species. We can move both your positive and negatively charged ions from your water across your ion exchange membranes into your concentrated stream. This purifies the water and comes out the top. What I've pictured here is one cell pair. Our technology combines over 100 cell pairs in one stack. This allows for a commercial scale application. You can then apply multiple stacks in parallel to scale up your application for very large cooling towers. What this means is that we can use both fresh water, which is most commonly used in cooling towers, but it also allows us to use alternative water sources such as reclaimed water, which is something that most people are trying to go towards, including here at the University of Texas. This reduces the operating cost by 20 to 30% by allowing you to reduce your makeup water use through increasing your cycles of concentration, and it also allows you to reduce your chemical use and disposal costs by 40 to 50% by improving your water quality to start with. What this means is that you have a payback period of less than 2 years when compared to conventional chemical treatment use. So our business model, we've gone through the LabCorp process, which is a DOE program very similar to I-Corps. And we decided through this process that we are going to be a water treatment OEM. We are going to manufacture this technology, this equipment. And as I said, we are going to sell it to the cooling tower owner and operator. But how are we going to do this is also very important. We are going to partner with the water treatment service companies. We're focusing on the smaller companies that have 10 to 20 trucks, something of that nature, because what they have existing sales force and relationship with the cooling tower owner operator. The cooling tower owner-operator currently specifies your water quality and heating load, and these water treatment service companies will come out multiple times a week to check on the system. What we plan to do is design this unit at cost to reduce your return on investment, and then how we're going to make money is through an already established service contract, which we will include a licensing fee for the technology, and then we will receive that licensing fee in the replacement resin wafers. Our cost structure is very simple. We need to manufacture our patented technology. We need to develop a supply chain for off-the-shelf components, have licensing fee back to Argonne since they own the patents, and very limited staff. Since we are working with our sales partners, we don't need to have a very large sales force. So our industrial market analysis, the total market, as I said before, is 500,000 cooling towers, but we're not after that. If we're going to go down to the first target market, we are looking at institutions in the southwestern part of the United States. The reason for that is that the Southwest has both lasting drought and very hard water. The hard water is the things that cause the scale and limit the cycles of concentration in the cooling tower, and the drought has caused them to start switching over to alternative water sources, which are dirty, and causing an issue as well. So we've estimated that there's about 5,000 cooling towers in our first target market, which has a 10-year market worth of about $21 million. So our product roadmap, first we're going to participate in the SEAL program to see if we can finalize our business model and answer the 5 questions that I've identified as the most important. We also have a small test unit at Argonne. It's a pilot unit from another project that we're going to install at a cooling tower on site. However, Argonne doesn't have any skin in the game. The water in Chicago is very cheap and very plentiful, so they're not going to have the same benefit as somebody in the Southwest. For example, our water is 85 cents per 1,000 gallons, and down here it's $7 per 1,000 gallons, so almost a factor of magnitude different. We also need to develop the supply chain, figure out who's going to sell us our off-the-shelf components and manufacture our resin wafer for us, and license the technology from Argonne. As many other people have said, we're aiming for SBR grants, hopefully the one that comes up in December, which will help us install the first proof of concept unit. Then phase 2 later in the year for the second proof of concept unit, and from there we are going to develop our marketing and sales strategy and start partnering with our water treatment service companies. So for competition, we've identified 3 major sources of competition. The first one is your traditional chemical treatment companies, which service most of your cooling towers currently. That's your Nalco, GE Water, and ChemTreat. They don't improve your water quality. Most people out there currently just manage the water that they're given. That's what sets us apart, is that we improve the water quality, which allows us to use a wider variety of water for your cooling tower system. The other section is the water softening technology. Water CTI is the biggest player in that space. However, what they do ends up leaving your water with a white residue, so it limits your applications. If you have drift, which is something, water droplets coming out of the top of your tower, if the drift goes over a parking lot, for example, then you can't use the water softening technology because you'll turn every car in your parking lot white. Other technologies, Silver Bullet and Dolphin, again, they don't improve the water quality, and they have limited applications where they have to use fairly clean water, so they can't use the alternative water sources. So the team is myself. I have been the lead on the LabCorp program. The other 2 team members currently are Yuko Lin and Seth Snyder. They have been developing this technology for the last 10 years, and both have over 25 years experience of R&D at Argonne National Lab. And we also have a very strong patent portfolio with over 14 US patents on both the material side and the application side, 2 additional pending patent applications, and 3 international patent applications. Any questions?
about how your cost of wafers compares on a 1,000 gallons treated basis to chemicals from Nalco?
So that's one of the things I'm still working on is economics. That's one of the four main things that I'm trying to answer. And the issue I'm having with that is to have someone tell me exactly what it costs for Nalco to treat their water. And then because we're not proposing to remove all chemical treatment, we're making the water better, but not perfect. So then to have someone say, okay, at this quality of water, it's going to reduce my chemical cost by 50%, 20%, something of that nature is one of the things that I really need to figure out still.
I'm sorry I missed your first slide, but as you talked through it, I was trying to figure out how big of a market is it really, and I don't mean the number of towers, but I mean how addressable is it?
Right.
And tied to that, how big of a problem is it for that addressable market? Even if you say 50% chemicals, the risk of a new process or other things. So can you talk a little bit about, or have you thought about how addressable that market is and how big is it really?
Right. So the reason why we selected institutions, universities, hospitals, data centers, airports, is because they have sustainability issues, which not only is there the economic benefit, then it also helps them meet their sustainability goals. We have talked to multiple different universities, their actual operators, and both of them have switched over to reclaimed water, and they are having serious issues. One university in California is upsetting the downstream wastewater treatment plant because they're adding in so many chemicals trying to manage the system. Here at University of Texas, I keep wanting to say Tennessee, I'm from Tennessee. At the University of Texas, they can't use 100% reclaimed water because it will cost them more money. So going from a $7 per 1,000 gallons to $1.50 per 1,000 gallon water, by increasing the volume of water that they're using and increasing the chemical use, they can't run on 100% reclaimed water without spending more money. So there's definitely a need for this.
So I didn't have any question about the problem or solution.
Okay.
My question really is the addressability. So frequently the people that actually you talk to that run it are not the people that write the checks.
Right.
So when I talk about the addressable market, I also mean, will they spend the money for this? Have you talked to people, the decision makers? And you don't have to answer now, but I think that's, when I look at this, if I'm an investor, that's one of the concerns I have is, yeah, you fix a problem, but the people that have to write the checks, not the people that are running the process.
Right.
Is this a big enough problem they'll write you a check?
Right.
For that?
Yes. So I have talked to those people, and the answer is yes. And also I've talked to the small water treatment service companies, and a lot of them have been very confident that the people, their customers trust them so much. If they say this will work, they'll install it. So we have somebody who's trusted that's a champion for our technology.
2 minutes.
So there are other markets, just to expand on the last question. So, things like brackish water treatment, and then also oil, fracking, all the treating of the frac fluids, that sort of thing. Have you looked into that as a potential larger market than we're looking at?
Yes. So when we started the LabCorp program, we looked at a very wide array of markets, and one of the things that they've harp on is finding something that you think is workable quickly so that you can focus on that. And we haven't discounted any of the other markets, we've just tabled them for right now. But yes, you are exactly right. There are a lot of different options. And the way we are setting up with a water treatment OEM, we can then go after those other markets as well.
One last question is, I'm assuming this technique also produces waste discharge, concentrated waste. What's the plan to deal with that?
So the concentration that we're looking at is still something put down your sewers, and it's such a small volume. If you've got any other water running through your sewer, it's going to dilute it so that it's not going to